Now, in the first video, I mentioned there are two different types of quadratic inequalities that we're going to deal with. The first type is the function type. So it's going to be function in its nature because it has two variables involved, okay? So it's going to be something like y is less than a quadratic, okay? So there are two variables involved, both x's and y's, and these are going to be things that we are going to graph. So your answer is a graph in that case, all right? Then the other type, which we're going to do in part 2 of this lesson, is the equation type, which means there's a single variable involved, all right? And that means we're going to have 0 with an inequality and a quadratic. Okay, single variable is the important thing here. And those are going to be solve problems. So our final answer is going to be the solution set, okay? So I'm going to make a little note over here. I'm going to make this in a different color. This is single variable versus two variables. All right. So let's talk about how to graph a quadratic inequality. We'll come back to the equation type, the solving type of problems later on. Okay, so to graph a quadratic inequality, the first thing you want to do is you want to find the vertex and at least two other points on the parabola. Okay, so we're limiting, instead of doing 5 points, we're just going to do 3. You can do 5 if you would like. Now I'm going to recommend whenever possible that you're going to do the x-intercepts if it is factorable. Because factoring is usually quick and easy. If you would have to do the quadratic formula or completing the square, then finding the x-intercepts, they probably won't be pretty answers, so they wouldn't be easy to graph, okay? So most of the problems we're going to look at, we are going to be able to find the x-intercepts by factoring. If not, then we would just make a table of values with another set of reflection points, okay? So then we are going to draw the parabola, or sketch the parabola. But because it's in inequality, we need to pay attention to whether it is a solid or dashed line. Okay. We do a solid line if it's less than or equal to, greater than or equal to. If there is no equal to, then we do a dashed line, okay? And like before, if you want to draw it solid and then label it as solid or dashed, that's totally fine, all right? And then we are going to, because it's an inequality, we're going to shade above or below the parabola. Oops, sorry. Based on, is it y is greater than or is it y is less than, okay? So we're going to find the vertex and at least one other set of reflection points, typically x-intercepts. Then we're going to draw the parabola with either solid or dashed line. Then we're going to shade above or below, okay? So we're going to refer back to our warm-up problem and then take a look at how will the graph be modified to go along with inequalities instead of equal to. All right, so let's take a look at that real quick. So what you see here is what I drew in our warm-up. Take a second, pause the video, and recopy that graph down. And then let's talk about how should we modify this graph so that it will match the inequalities. All right, so we're making a rough sketch. So we already have our vertex. We already have our x-intercepts. We already have our parabola drawn. The question is, how do we modify? Okay. All right, so taking a look at this first one, y is greater than or equal to. All right. This right here is telling me equal to solid line. Not, and then, sorry, tripping over my words here. Y is greater than or equal to the parabola. Okay, so y is greater than or equal to the parabola is how I read this, okay? Greater than or equal to means shade above. So I don't have to change the line itself because it should be a solid line, but I do need to shade now. So I'm going to shade above. So that's going to be everything up on the outside of the parabola is going to get shaded. Okay. And you want to cover your entire grid completely. All right. If you're not sure if you're shading the right direction, you could always pick a point, say for example 0, 0, and plug it in. If it works, it should be in the shaded area. If it doesn't work, it should not be in the shaded area. Okay. So then what about the other one? What about the one off to the side? So now I see y is less than, okay? Y is less than a parabola. Well, because it's less than with no equal to, this should be a dashed line. So I'm going to have to get creative on how I'm going to fix this. So I'm going to draw it with a dashed line instead. And since it's y is less than, I'm going to shade below. All right. So let's see. I need to make this into a dashed line. So I'm going to erase some parts. Make it a dashed line parabola. Again, it is okay for you to just draw it with a solid line and then label it as being dashed. That is okay for you to do. I know drawing a dashed line parabola is not the easiest thing in the world. I personally am not great at it. All right, so there's my dashed line. And now I want to shade below. Below the parabola is inside in this case. Okay. There we go. Again, you could do a confirmation point. Always think above or below and use the vertex as a point that can kind of help you. Think about, am I shading above the vertex or below the vertex? And that will help you to figure out if it's inside or outside. All right. We're going to go through one more final example, but I'm going to put it in a separate video so that this doesn't get to be too long. All right. See you there.